Welcome everyone. In this class, we'll learn the disproportionation and comproportionation reaction, which is basically the part 2 of this redox reaction, and it is also a very important topic. So first of all, we'll learn the disproportionation reaction and then the comproportionation reaction. So what is basically the disproportionation reaction? Disproportionation reaction is one kind of redox reaction in which same substance is oxidized as well as reduced, and hence the substance can act as an oxidizing agent as well as a reducing agent in the same reaction, and that kind of reaction can be named as disproportionation reaction. মানে সোজা কথায় বলতে হলো যে disproportionation reaction হলো সেই ধরনের রিঅ্যাকশন যেখানে সেম সাবস্টেন্সই আমার অক্সিডাইজড হচ্ছে আর সেম সাবস্টেন্সই আমার রিডিউসড হচ্ছে একই রিঅ্যাকশনে, অথবা সেম সাবস্টেন্স আমার অক্সিডাইজিং এজেন্ট হিসেবে আর সেম সাবস্টেন্স আমার রিডিউসিং এজেন্ট হিসেবে কাজ করছে। So first I will just explain you what is basically the oxidizing and reducing agent. What is the reducing agent? Reducing agent means that which is reduce something, or actually it is having the property to reduce other agent, okay, or other substance. And what is the oxidizing agent? Oxidizing agent means that it has the property to oxidize other substances, and reducing agent means it has the property to reduce other substances. So that means that it will be oxidized itself. If it is an reducing agent, that it has the property to reduce other substance, then itself it will be oxidized. Or if it is having the oxidizing, if it is an oxidizing agent, then it will have a property to oxidize other substance. Therefore it will be reduced itself. মানে কি, যদি রিডিউসিং এজেন্ট বলতে হয় তার মানে কি, তার মানে সে অন্যকে রিডিউস করছে, তার মানে সে নিজে অক্সিডাইজ হবে। অক্সিডাইজিং এজেন্ট মানে কি, সে অন্যকে অক্সিডাইজ করছে, মানে সে নিজে রিডিউস হবে। ওকে, তাহলে এটা হচ্ছে অক্সিডাইজিং এজেন্ট অথবা রিডিউসিং এজেন্টের অল ওভার একটা বেসিক আইডিয়া। তাহলে অল ওভার ডিসপ্রপোর্শনেশন রিয়াকশন বলতে আমরা কি বুঝবো, যে আমরা এতক্ষণ যে রেডক্স রিয়াকশন পড়েছিলাম, যে একটা রেডক্স রিয়াকশন মানে সেখানে রিডাকশন এবং অক্সিডেশন সাইমালটেনিয়াসলি একই সাথে হচ্ছে ওই রিয়াকশনে, এখানেও তাই হবে, এটাও এক ধরনের রেডক্স রিয়াকশন। কিন্তু এখানে সাবস্টেন্সটা কিন্তু একটাই, যে অক্সিডেশন এবং রিডাকশনে পার্টিসিপেট করছে, অথবা যে কিনা অক্সিডাইজড এবং রিডিউসড হচ্ছে, অথবা যে অক্সিডাইজিং এবং রিডিউসিং এজেন্ট হিসেবে কাজ করছে, সাবস্টেন্সটা এখানে একটাই। ফর এক্সাম্পল আমরা এখানে দেখাতে পারি যে, for example we are taking like chlorine plus 4H minus being converted into 2ClO minus plus 2H2O plus 2Cl minus. Okay, now here the oxidation state of chlorine would be 0. Okay, it would be chlorine, oxidation state of each chlorine would be 0. It is in the molecular form. But here in case of ClO minus, the oxidation state of chlorine would be +1. Why? Because you can take the oxidation state of chlorine equals to X, and the oxidation state of oxygen is -2. So all over it would have -1. The all over charge is -1. So X minus 2 equals to -1, then X equals to +1. Okay, the oxidation state of chlorine would be +1. And here in case of Cl minus, the oxidation state of chlorine is -1. Okay, so now what is basically the oxidation process and the reduction process? So now this chlorine is being changed to this chlorine plus. So this would be basically oxidation process, and this chlorine is being changed or being transferred means this chlorine is being changed to Cl minus, so therefore it would be a reduction process. So this is basically the oxidation and reduction reaction. So all over it will be a redox reaction, but think that in these reaction there is some difference. The difference is that here the substance is same, so the chlorine 1 Cl2 is being oxidized to Cl plus, whether another Cl2 is being reduced to Cl minus. So the same substance is being reduced and the same substance is being oxidized. Okay, so which Cl2 is actually an oxidizing agent and which Cl2 is actually acting as an reducing agent? So the oxidizing agent means that it is oxidizing the other substance, so itself it is reduced. So this chlorine has a property that it is actually being oxidized, so it has the property to be oxidized or has the property to reduce others. So this is basically the reducing agent. This is basically the reducing agent. Why? Because it is reducing the other Cl2, the other chlorine, and itself it is actually oxidized. So therefore it will be a reducing agent, so it is having the reducing property, or it can reduce other substances, or itself it will be oxidized. Now this Cl2 will be an oxidizing agent. Why? Because itself it is reduced to Cl minus, so it is having a property to be reduced itself or oxidize other substances. This Cl2 is actually being reduced itself to Cl minus, whereas it is oxidizing the other chlorine to Cl plus. So therefore it is having the oxidizing property, or it can oxidize other substances. So the first Cl2 is actually acting as reducing agent, while the other Cl2 is actually acting as an oxidizing agent. So this is basically an example of disproportionation reaction where the Cl2 itself behaves as an oxidizing agent as well as an reducing agent in the same reaction, or it actually the same substance, that is the Cl2 itself, is reduced or oxidized in the same reaction. It is oxidized and as well as reduced in the same reaction. Okay, so this is basically one of the example of disproportionation reaction. We can take another example like H2O2 is reacting with another H2O2 to be converted to water plus O2. Now you have to calculate the oxidation state of oxygen. Now here the oxidation state of oxygen is -1 in both of the H2O2, but in case of H2O the oxidation state of water is -2, whereas in case of molecular oxygen the oxidation state of oxygen would be 0. So now here, which one is the oxidation process and which one is the reduction process? So here from this H2O2 to this H2O, the oxidation state of oxygen actually changes from -1 to -2. So therefore the oxidation state is being decreased. Therefore it is actually a reduction process. Whether with another process, that is from this H2O to this oxygen, the oxidation state of oxygen is being changed from -1 to 0. So therefore the oxidation state is being increased from -1 to 0, and hence the process can be named as a oxidation process. So therefore this is basically the oxidation and reduction process which we have already come to know. Now you should think about this reaction in such a manner that these two H2O2 is a similar substance, right? But one H2O2 is being reduced to H2O, whether another H2O2 is being oxidized to O2. So there is a similar substance, that is H2O2. It is oxidized and as well as reduced in the same reaction. Or one H2O2 is acting as an oxidizing agent, and another H2O2 is acting as a reducing agent in the same reaction. Now which H2O2 is acting as an oxidizing agent? Say for this H2O2, it is actually being reduced to H2O. So it is having the property to be reduced itself or to oxidizing the other H2O2. Okay, so now this H2O2 would be this H2O2 would be an oxidizing agent, right? Because it is actually oxidizing other H2O2, whereas itself it is reduced, and this H2O2 is actually itself reduced to O2, that is the oxidation state of oxygen changes from -1 to 0, whether this H2O2 is actually having the property to reduce others. So therefore it will be a reducing agent. Okay, so the substance is same, that is only H2O2, but one H2O2 is actually acting as oxidizing agent and another H2O2 is actually acting as a reducing agent. One H2O2 is actually being oxidized to O2 while another H2O2 is being reduced to H2O. So the substance would be similar. So in both of the cases, actually the substance is having an intermediate oxidation state, and from that oxidation state it is undergoing an oxidation process, whether the oxidation state is being increased, and in another process, that is the reduction process, or through reduction process the oxidation state of that substance is being reduced from the original oxidation state. So this is basically the examples of disproportionation reaction. Now we'll look into the comproportionation reaction. So the disproportionation reaction, whatever we have learned, comproportionation reaction is just the complete opposite of that disproportionation reaction. So whatever you have learned in disproportionation reaction, that same substance is reduced and oxidized, and from one intermediate oxidation state it is jumping to a higher oxidation state, and in other case the oxidation state is being reduced from the initial oxidation state. Now in case of comproportionation reaction, two species of a particular substance with different oxidation states will combine to form a product having an intermediate oxidation state. Okay, so it is just the complete reverse or complete opposite case of a disproportionation reaction. We can take an example here also, that is, for example, one silver 2 plus aqueous ion is reacting with one silver solid and being converted to silver plus aqueous ion. Okay, so now in these process, actually this silver 2 plus is being converted to silver plus, so this would be basically a reduction process, where the silver 0 would be converted into silver plus. This would be a oxidation process, because in the first case the +2 oxidation state is being changed to +1, so this is basically the oxidation state is decreasing, therefore it would be named as a reduction process. Whereas in the second case, the silver 0, that is silver solid, is being converted to silver plus, the oxidation state is being increased and hence it can be named as a oxidation process. So therefore these are basically the two process we have already known so far, that is the oxidation and reduction process. Now in this case, the silver is having two different oxidation states, that is having one +2 oxidation state and having one's 0 oxidation state. Now this 2 oxidation state of silver 2 is actually reacting with each other to give an intermediate oxidation state, that is +1, and this +1 actually lie in between +2 and +0. So this is basically the actual definition of comproportionation reaction, that is the reaction of two species of a particular substance with different oxidation states actually combining to each other to give a product which is having an intermediate oxidation state. Okay, in this case also the same substance is actually acting as an oxidizing agent and acting as a reducing agent in the same reaction. Okay, so now the forward reaction is actually a comproportionation reaction, and the backward reaction you can say that it is a disproportionation reaction, as we have already told that comproportionation reaction is just completely opposite of disproportionation reaction. In the earlier slide also, the forward reaction here, it is actually a disproportionation reaction, where the backward reaction would be a comproportionation reaction in both of the examples. And in case of comproportionation reaction, whatever we have seen in this slide, side, the intermediate oxidation to do different oxidation states of silver, that is +2 and 0 oxidation state, is reacting with each other or combining with each other to give a product of silver which is having just +1 oxidation state or an intermediate oxidation state which lies in between +2 and +0 oxidation state. Okay, so this is the example of comproportionation reaction. So we will look into an mathematical problem now. So the problem is that, will copper 1 disproportionate into aqueous solution into copper 2 and copper? It is a question where the some data are given, that is E0 of Cu2 by Cu, it is 0.52 volt, and E0 of Cu2 by Cu1 is 0.153 volt. Okay, so now we are just trying to have the math. So the step 1 should be, the step 1 is to write the actual to write the redox reaction in a proper way. So now this copper 1 is disproportionate. So disproportionation means that the same substance is undergoing the oxidation and reduction reaction, or it is oxidized or reduced in the same reaction, or it is acting as an oxidizing agent or the reducing agent in the same reaction. So in the left hand side it would be copper 1 or copper plus copper plus, right? So this is basically this disproportionation. So in the left hand side then in the right hand side it would be then 1 copper plus should be oxidized to copper 2 plus, and another copper 2 plus should be reduced to copper 0, right? So this is basically the disproportionation reaction of copper 1. I think that you have already understood this thing at least. So now we should have a step 2, that is the electrochemical reaction. So basically in the middle there will be a salt bridge. In the right hand side there will be the cathode, which is having the reduction process. So in the right hand side it would be, the reduction is copper plus to copper 0, right? This is a reduction. So there would be Cu plus by Cu. And the left hand side, this is the anode or the oxidation process. The oxidation process is Cu plus to Cu2 plus, and we will write this as Cu plus by Cu2 plus as the oxidation process. Now there would be the step 3. So step 3 is that E0 cell. So E0 cell equals to E0 reduction of right hand side minus E0 reduction of left hand side. So basically E0 reduction of right hand side means we have in the right hand side copper plus by copper. So reduction means E0 Cu plus by Cu, right? And the left hand side we have the group Cu plus and Cu2 plus, but we should write in the term of reduction potential. So therefore we should write E0 of Cu2 plus by Cu plus, not Cu plus by Cu2 plus. We should write in the term of reduction potential. So therefore E0 of Cu plus by Cu is already given, that is E0 of Cu plus by Cu is already given, that is 0. This is Cu plus by Cu. I have mistakenly written as Cu2 by Cu. This Cu plus by Cu. Okay, so is mistakenly written as Cu2. So Cu plus by Cu is actually having the value of 0.52 volt minus Cu2 plus by Cu plus is having the value of 0.153 volt. So all over it would be almost 0.367 volt. So actually we are getting that E0 cell equals to positive. So E0 cells positive means del G0 equals to minus NF E0 cell. We do not have to calculate the del G0 value. We just have to write the equation that as E0 cell is positive, so therefore del G0 would be negative, and hence the process would be spontaneous. And hence this process would be spontaneous. So as this process would be spontaneous, so therefore the equilibrium will be shifted to the right hand side, or you can say that definitely Cu1 will disproportionate in aqueous solution into copper 2 and copper, or the disproportionation reaction will be preferred, or copper 1 will undergo the disproportionation reaction. Okay, so therefore we have already seen that there are 3 steps. Step 1 is To write the redox reaction properly, step 2 is the electrochemical cell to draw the electrochemical cell in a proper way, and step 3 to calculate the E0 cell by our conventional method. And by calculating the E0 cell, you can correlate with the equation that is del G0 equals to minus NF E0 cell. And now if E0 cell is positive, then del G0 would be negative, which determines the spontaneity of the reaction. Now in this case, E0 cell has come as positive, so therefore we can say that as E0 cell is positive, del G0 equals to minus NF0 cell equals to negative, which means that copper 1 will undergo the disproportionation reaction into aqueous solution to give copper 2 and copper. Okay, so in this class we have learned what is the disproportionation reaction, what is the comproportionation reaction. In disproportionation reaction, how the substance is being oxidized and reduced in the same reaction, how the substance is acting as an oxidizing agent and reducing agent in the same reaction, and how the oxidation state is being changed, we have already seen through different examples. And in the comproportionation reaction, we have already seen that the comproportionation reaction is just the complete opposite or completely reverse of disproportionation reaction. Similarly, a disproportionation reaction is also completely reverse of comproportionation reaction. In comproportionation reaction, we have seen that the substance with two different oxidation states is combining with each other to be converted into a product which is having an intermediate oxidation state, and that intermediate oxidation state is actually lying in between the oxidation states of the starting materials. Okay, so we have already understood the mechanistic aspect of disproportionation and comproportionation reaction, and through that concept we have already applied it into a math to just clear our concept in a more convenient way. So thank you very much for watching this video, and if you have any doubt regarding this class, you can directly contact us at NS Institute through the website www.nsinstitute.com, or you can drop us a mail at nsinstitute@gmail.com, or you can directly call, message or WhatsApp us in the given number. Thank you very much for watching this video.